Here's a quick overview of how to do these problems. So in this problem, you see we've got beryllium oxide we're trying to make. Beryllium has a +2 oxidation state because it has 2 valence electrons. So we'd say that's a +2. I have to write it over here. So beryllium, whoops. Beryllium is a +2 oxidation state. So Be with a +2. And oxygen has 6 valence electrons, so it's going to have a -2 oxidation state. All right, in the first equation over here, you can see that to remove the 2 electrons from beryllium, it takes a total of 2,660 kilojoules of energy. Then we had to sublime that. Before we could even remove those electrons, it had to be sublimed to go from a solid to a gas, and that took 302 kilojoules of energy. We needed to break the oxygen from a molecule, because oxygen occurs diatomically. We needed to break it into individual atoms. Well, if you do this, you get 2 atoms of oxygen. See the 2. Well, we only needed how many atoms in our formula? We only have 1 atom of oxygen here. So we're going to need to divide the 488 into 2 and make it 244, because I only need half of the amount that's listed here. I only need 1 O, and this would give us 2 O's. So 488 gives us 2 O's. 244 would give us 1 O. Okay, and then the 2 electrons get added to the oxygen. You will remember that when you add electrons, usually you expect energy to be released, but in class we talked about the problem with adding the second electron to oxygen. It's more crowded after the first electron has been added, and so it actually takes energy or requires energy to make the second electron stick in. I'm just going to quickly draw that. So here's 1, 2, 3, 4, 5, 6 electrons in the outer shell of oxygen. I can put another one in there, and you get an electron affinity that's negative. So it's a negative electron affinity. That means energy is released. But when I add the second electron, that's actually a positive electron affinity, because when you add the 7th electron in the outer shell, it makes it more crowded, and so now those 7 electrons repel the 8th electron, so it takes energy to make the electron stick. And so that, in short, this is a positive number because you're adding both electrons to oxygen, not just one. Okay, we don't know what the lattice energy is. That's this blank right here. And we know that the total of all those things added together would be -614. So I'm going to take a moment to pull out my phone. I'm just going to do this on my phone on the side, and open my calculator app, and I'm going to add 2660 and 302 and 244 and 598. And when I do that, if I did it correctly, I get 3,804. So that's the top line, and I'm going to add to that x. And after I have added x to whatever 3804 is, I should get -614. Equals -614. All right, so to solve for x, we subtract 3804 from both sides. And I get x equals -4,418. -4,418. So over here, I put in a -4418. I hit check answer, and you notice how down at the bottom it says that there is now 1 correct. Okay, so we're going to do another problem. Now this one, let's see if I can just select everything over here. Probably can't. So we'll just erase a little bit. Didn't quite get it all erased. All right, what are you just going to write on this pad? So for this one, we've got sodium, making sodium sulfide. Now, just to review this oxidation number stuff, the sodium, Na, is a +1 oxidation state because it's got one valence electron. The sulfur is -2. That's why we have 2 atoms of sodium, because in order to get the sodium to bond with the sulfur, you're going to have, since that's a +1 charge, I'm not making that very clear, so that's +1. You have to have 2 +1s to match the -2. All right, so we write our numbers down. Since you've got sodium up here going to +1 and an electron, how many times will that need to happen? Well, twice, because there's 2 of them. So you'd have 486 plus 486, or just 2 times 486. So 486 plus 486. I'll put that in parentheses to remind you that that both is related to losing the electron from sodium. You'd also have to sublime to get 2 atoms of sodium. So 98 and 98, or 2 times 98. That's the second row over here. This 1 atom of sulfur is fine because you only have 1 atom in your formula. You've got 1 atom of sulfur in the formula again for electron affinity, so there you go. And again, this is a positive electron affinity for the same reason that oxygen was a positive electron affinity. Then this is your lattice energy, which we don't know. And this is your overall energy change. So I'm going to go ahead and add the other numbers up. Remember, 1 sulfur, so I just leave those 2 numbers alone the way they stand. So it has 264. So plus 264 and plus 246. Plus x equals negative 368. All right, so again on my phone, I'm going to do this, put the final summation right in here in this little space right there. So again on my phone, I'm going to have 486 times 2 plus 98 times 2 plus 264 plus 246. And I get 1678. So up here I got 1678 plus x equals negative 368. So subtract 1678 from both sides. And I get negative 2046. So x equals negative 2046. That's fairly alarming. That's a little joke there. All right, so we put in negative 2046, and hit check answer. And now you'll notice we have 2 correct down here. So that's how you do these problems.